Now next question is, if the function fx is given to be this is this for x greater than 1, 11 for x equal to 1, equal to this for x less than 1. We are given that the function is continuous at x equal to 1 and we have to find the values of a and b. What we note here is, for x greater than 1, definition of the function is this. For x less than 1, it is this. So definition of the function is changing for x greater than 1 and x less than 1. So we must consider left and right limits separately. What we do is, we first find a limit x approaches 1 from positive side fx. This is equal to limit x approaches 1 from positive side. Now as x approaches 1 from positive side, x is greater than 1. This means x is greater than 1. This is the number line. This is 0. This is 1. We are approaching 1 from this side. That is from points greater than 1. So this is x greater than 1. So greater than 1, definition of the function is 3ax plus b. Now this is not in the 0 by 0 form, so we can directly substitute. This is not in indeterminate form. This is equal to 3a plus b, say 1. And limit x approaches 1 from negative side fx is equal to limit x approaches 1 from negative side. This will mean x approaches 1 from negative side, x is less than 1. So value of the function is this. Therefore fx is equal to 5ax minus 2b. Here fx is equal to 3ax plus b. So this is the definition of the function. So we have 5ax minus 2b. Again, this is not in indeterminate form. So we can directly substitute the limit. So this will be 5a minus 2b. And value of the function at the point 1 is given to be 11. So this is say 2, this is 3. Now limit x approaches 1 from positive side fx must be equal to limit x approaches 1 from negative side fx is equal to value of the function at 1. Now 1 from positive side is 3a plus b. This is 5a minus 2b and this is equal to 11. Now these must be equal. Now to find a and b, we need two equations because two unknowns are there. Therefore we must have two equations. So first equation is 3a plus b is equal to 11 and second equation is 5a minus 2b is equal to 11. So what we do is, this is say 5, this is 6. Multiply 5 by 2. So 2 into 5. 2 into 5 implies 6a plus 2b is equal to 22. Now add these two equations. Add these two. What we get is, this is 11a, these two cancel and we get this equal to 33. Therefore a must be equal to 3. Therefore a must be equal to 3. Now substitute a in 5. Now 5 implies b is equal to 11 minus 3. This is equal to 11 minus 3 into 3 is 9. So this is equal to 2. So a must be 3 and b must be equal to 2. Therefore, for continuity, a must be equal to 3 and b must be equal to 2. Because for continuity, this condition has to be satisfied. And from this condition, we got this equation. From where we generated these two equations, solved them simultaneously and got the values a equal to 3 and b equal to 2. Now in this question, we are given this function and we have to find the values of a, b, c for which this function is continuous at x equal to 0. So we have to discuss the continuity at the point x equal to 0. Now fx is given to be this and we have to find a, b, c so that this function is continuous. Now for x less than 0 we have this definition, and for x greater than 0 we have this definition. Therefore we must consider left and right limits separately. So first I find limit x approaches 0 from positive side fx. This is equal to limit x approaches 0 from positive side. Now x approaches 0 from positive side means x is greater than 0. X is greater than 0 in neighborhood of this point 0. We only consider points in the neighborhood of the point 0. X greater than 0, we will use this definition. So we have under root x plus bx square minus under root x whole divided by bx to the power of 3 by 2. And this can be written as limit x approaches 0 from positive side under root of x is common 1 plus bx minus under root x whole divided by b, and x to the power of 3 by 2 can be written as x root x. Now what we see in the numerator, under root x is common. Under root x from here and under root x from here, it is common. So under root x is common and we are left with under root of 1 plus bx minus 1 whole divided by bx root x. Now root x cancels here and we are left with this. In this we must rationalize the numerator. We must rationalize the numerator. This is equal to limit x approaches 0 from positive side. We are left with under root of 1 plus bx minus 1 whole divided by bx, and we must rationalize this numerator, because when we put x equal to 0, this will be 1 minus 1 is 0, 0 by 0 form. This is in 0 by 0 form. Originally the question was in 0 by 0 form. We have not been able to remove 0 by 0 form, the indeterminate form. So what we do is we rationalize the numerator, that is multiply by 1 plus bx plus 1. This is a minus b, we multiply by a plus b and divide by under root 1 plus bx plus 1. Now a minus b into a plus b is a square minus b square, so this root will be removed. Limit x approaches 0 from positive side, we will have, now square of this is 1 plus bx. 1 plus bx minus b square. 1 square is 1. And we have bx into under root of 1 plus bx plus 1. Now this cancels and bx also cancels with bx. So this also cancels with this. We have cancelled bx. So we have x approaches 0 from positive side. This will mean x is not equal to 0. But we have also cancelled b. So here we are assuming that b is not equal to 0. We are assuming b is not equal to 0. Assume b is not equal to 0. Because before cancelling b, we must know whether b is 0 or not. If b is non-zero, then only we can cancel b. So we are assuming here that b is not equal to 0. And you must remember that we have assumed b is not equal to 0. So now this is not in 0 by 0 form, so we can directly substitute the limit. And what we get is, in the numerator we have 1, and in the denominator we have root 1 plus 0. That is root 1 plus 1. That is 1 by 2. So right limit is 1 by 2. Now we find the left limit. Now limit x approaches 0 from negative side, fx is equal to. X approaches 0 from negative side means x is less than 0. And therefore the definition of the function that will be used is fx is equal to sine of a plus 1x plus sine x whole divided by x. You can see the side sheet. So this is equal to limit x approaches 0 from negative side, sine of a plus 1x. We are separating these two terms. And limit x approaches 0 from negative side, sine x by x. So this is equal to, now here we have sine a plus 1x, so we must have a plus 1 in the denominator. So we must write this as limit x approaches 0 from negative side, sine a plus 1x divided by a plus 1x. We are dividing and multiplying by a plus 1. And this limit x approaches 0 from negative side, sine x by x. Now this limit is 1, and this limit is also 1. Limit of both these terms is 1. So we have a plus 1, this is 1, a plus 1 plus 1. So left limit is a plus 2. And for continuity, limit x approaches 0 from positive side, fx must be equal to limit x approaches 0 from negative side, fx, and this must be equal to the value of the function at the point 0. So right limit, now right limit is from 1, right limit is 1 by 2, and say this as 2, from 2 left limit is a plus 2, and value of the function at the point 0. See the definition of the function given in the question. At x equal to 0 we have fx is equal to c, and this implies a is equal to, now take 2 to the other side, we will have minus 3 by 2, and c is half, and there is no restriction on b, but we have cancelled b, and at that stage we assumed b is not equal to 0. So here in the answer we must write b is not equal to 0, or we can say b belongs to R. B can be any real number except 0. B can have any value, the function will be continuous for that value, but that value must be non-zero. Now this question you can try on similar lines. 1 minus cos theta, 1 minus cos 2 theta is 2 sine square theta. Use that formula. This will become in terms of sine square x. X square will be adjusted and you will get the limit. And here you must rationalize the denominator. That is, this will be under root of x divided by under root of 16 plus root x minus 4. So you must multiply and divide by under root of 16 plus root x plus 4, and here you must have under root of 16 plus root x plus 4. Multiply and divide by this. So that this is a minus b into a plus b. So we will get a square minus b square. So this under root will get cancelled. And we will have 16 plus root x minus 16. 16 cancel, then the question will be solved. So you can try this yourself. Now I come to the next question. In this question, what we see is we have to discuss the continuity at x equal to pi by 2 and trigonometrical functions are involved. In limits, we studied that limit x approaches 0, sine x by x is 1 and limit x approaches 0, tangent x by x is also 1. So both these formulae are available for x approaches 0 and here the point is x equal to pi by 2. So we have to change it into limit x approaches 0, limit which tends to 0. Now fx is given to be this and we have to discuss the continuity at the point x equal to pi by 2. For x greater than pi by 2, we have this definition. For x less than pi by 2, we have this definition. So we must consider left and right limits separately. So what we do is, first is limit x approaches pi by 2 from, say, first I take negative side, fx. So this is equal to limit x approaches pi by 2 from negative side. X approaches pi by 2 from negative side means x is less than pi by 2. X is less than pi by 2, so this definition will be used. We have 1 minus sine cube x over 3 cos square x. And now to change this into 0 limit, what we do is we put pi by 2 minus x equal to t. What we note here is, from here what we see is that pi by 2 minus x is greater than 0. We generally put this equal to 0, which is positive. If x approaches pi by 2 from positive side, we will have x is greater than pi by 2. So x minus pi by 2 will be positive and we will put x minus pi by 2 equal to t. If it is left hand side limit, we will put pi by 2 minus x equal to t because this is positive. Now as x approaches pi by 2 from negative side, t approaches 0. T will approach 0. This will be positive because x will be less than pi by 2. Pi by 2 minus pi by less than pi by 2 will be positive. And we will write x approaches pi by 2 from negative side, t approaches 0. And we can write 1 as 1 implies limit x approaches pi by 2 from negative side fx. This is equal to limit t approaches 0, 1 minus. Now x, how much is x? X is pi by 2 minus t. Pi by 2 minus t. So we will have sine cube pi by 2 minus t whole divided by 3 cos square pi by 2 minus t. And this is equal to limit t approaches 0. Now pi by 2 minus t lies in first quadrant. So this will be positive and this is an odd multiple. Therefore t ratio must change. We must have 1 minus cos cube t. And here we must have 3 into. Now cos of pi by 2 minus t, first quadrant, and pi by 2 minus t, therefore cos will become sine. This is sine square t. This is sine square t. A very useful tool of converting t ratios of n pi by 2 plus minus theta to t ratios of theta, which I have used here. So the rule consists of two steps. Step 1 is decide sign according to all sine, tan, cos. And step 2 is first, if n is even, no change in T ratio. If it is sine, it will remain sine. It is cos, it will remain cos. It is tangent, it will remain tangent. And second is, if n is odd, add or delete co. That is, sine will become cosine. Tangent will become cotangent. Cotangent will become tangent. Secant will become cosecant. Cosecant will become secant. For example, say sine of 3 pi by 2 plus theta. Sine of 3 pi by 2 plus theta. Now sine of 3 pi by 2 plus theta. This is pi by 2, 2 pi by 2, 3 pi by 2. 3 pi by 2 plus theta is in fourth quadrant. In fourth quadrant, sine theta is negative. So we will write a negative sign here. This is step 1. And step 2 is, now n here is 3. 3 pi by 2. So we will attach or delete co. So sine will become cosine. So sine will become cos theta. Done. If it is, say, secant of pi minus theta, secant of pi minus theta. Now pi minus theta, this is pi by 2, this is pi. Pi minus theta is in second quadrant. In second quadrant, secant theta is negative. So we will have negative sign, and this is 2 pi by 2. Pi is 2 pi by 2. So it is an even multiple of pi by 2. So no change in T ratio. So secant will remain secant. And similarly, you can do others. So this is equal to limit T approaches 0. This can be factorized into 1 minus cos T into a cube minus b cube is a minus b into a square plus ab, a into cos t, that is cos t plus b square. B square is cos square t. A cube minus b cube is a minus b into a square plus ab plus b square, whole divided by 3 sine square t. This is equal to limit t approaches 0, 1 minus cos into 1 plus cos t plus cos square, whole divided by 3 sine square t. Now this is the solved part. See the side sheet. So this is the solved part, and we concentrate only on these two terms. This is limit t approaches 0. Now 1 minus cos t. Formula is in terms of sine or tangent. So 1 minus cos 2 can be written as 1 minus cos 2 theta is 2 sine square theta. So this will be 2 sine square t by 2. It is 2 theta, it is theta here. And this will remain as it is. This is the solved part. We need not do anything for this. Whole divided by 3 sine square t. Now this can be written as limit t approaches 0, 2 into sine t by 2 whole square into 1 plus cos t plus cos square t whole divided by 3 sine t whole square. Now what we do is, formula is limit x approaches 0, sine x over x is 1. So we make t by 2 here. So t by 2, so we adjust t by 2 here. This will be t by 2 whole square. And it is sine t, so we make t here and adjust t. So this t square and this t square cancels, and we are left with, this will be 2 into, this will be 1 square, limit is 1 into 1 plus cos 0 is 1 plus cos square 0 is 1, and t cancels with this, so we are left with 1 by 2 whole square, and this will be 3 into 1, 3 into 1 square. This cancels with this, and so on simplification we get 2 into 3, this is 4, so 3 2s are 6, 6 by 4, and this is 3, so 6 by 12, 6 by 12 is half. Now we find limit x approaches pi by 2 from positive side fx. Now we find limit x approaches pi by 2 from positive side fx. Limit x approaches pi by 2 from positive side. Now this means x approaches pi by 2 from positive side means x is greater than pi by 2. And we can also observe x minus pi by 2 is greater than 0. So x is greater than pi by 2. So which definition will be used? It is the last one. That is b into 1 minus sine x over pi minus 2x whole square. Because for x greater than pi by 2, fx is this much. Now we have to reduce it into zero limit. So we put x minus pi by 2 is equal to t. So as x approaches pi by 2 from positive side, t approaches 0. This will be positive. So t approaches 0, we can write. And this limit will be equal to limit t approaches 0 b into 1 minus sine, and how much is x? X is pi by 2 plus t whole divided by pi minus 2 into x. X is pi by 2 plus t. So we get limit t approaches 0 b into 1. Now pi by 2 plus t. So pi by 2 plus t is in second quadrant. In second quadrant, sine is all sine, tan, cos. So sine is positive. So we will have positive sign. So this will be minus, and this is odd multiple. So we will have cos of t. 1 minus cos t. And whole divided by pi minus. This cancels. We will have pi. Pi cancel, and minus 2t will be left. So this will be minus 2t. This will be minus 2t. This is minus 2 into this cancels with this, and we are left with minus 2t. So this is equal to limit t approaches 0 b into 1 minus cos theta. 1 minus cos theta is 2 sine square theta. So we can write this as 2 sine square t by 2 whole divided by, sorry, there is a square here. So we have this, and this will be square. So we have this, and here we get 4t square. 4t square. p by 2 into sine t by 2 divided by t whole square. This is square, this is square. So we can write sine t by 2 over t whole square. Now we must have t by 2 here. So divide by 2 and multiply by 2. Now this limit is 1. So we will have b by 2 into 1 by 4. That is b by 8. Now let this be 2 and this be 3. Now for continuity, limit x approaches pi by 2 from negative side fx must be equal to limit x approaches pi by 2 from positive side fx must be equal to value of the function at the point pi by 2. So this is from 2, this is equal to 1 by 2, and from 3 this is equal to b by 8, and value of the function at pi by 2 is, from definition of the function, it is a. See the side sheet. Therefore b must be equal to 4 and a must be equal to half. Therefore b must be equal to 4 and a must be equal to half. Now next question is, if fx is equal to this much, is continuous at x equal to 2, find k. Now in this question, the formula that will be used is, we can see from the form of the question, limit x approaches 0, a to the power of x minus 1 whole divided by x. This is log of a. And a connected formula to this is limit x approaches 0, e to the power of x minus 1 over x is log of e. Log is 1. So this formula will be used in this question. And this, in this formula, what we see is limit is x approaches 0. Now in this question we have to discuss the continuity at x equal to 2. So we must find limit x approaches 2 of fx. So we must change this into x approaches 0. Only then we will be able to use this formula. So we must change this limit into 0 limit. Now x approaches 2 means x is not equal to 2. So x is not equal to 2, this definition will be used, and we will have limit x approaches 2 to the power of x plus 2 minus 16 whole divided by 4x minus 16. 4x minus 16. Now to convert this into 0 limit, what we do is put x minus 2. X minus 2 will be 0. X minus 2 equal to t. Now as x approaches 2, t will approach 0. As x approaches 2, t will approach 0. So this can be written as limit x approaches 2 of fx can be written as limit t approaches 0. X approaches 2 will change into t approaches 0. And this will be 2 to the power of, now x. How much is x? X from here is, x is equal to 2 plus t. So this is 2 to the power of t plus 2 plus 2 minus 16 whole divided by 4 to the power of t plus 2 minus 16. So this is equal to limit t approaches 0, 2 to the power of t into 2 to the power of 4. This is 2 to the power of t plus 4. This can be written as 2 to the power of t into 2 to the power of 4. And 16 is again 2 to the power of 4. And this is 4 to the power of 2 into 4 t. This can be written as 4 to the power of 2 into 4 to the power of t minus this is again 4 to the power of 2. So this can be simplified into limit t approaches 0. Now 2 to the power of 4 is common. 2 to the power of 4 is common. We are left with 2 to the power of t minus 1 whole divided by 4 to the power of 2 into 4 to the power of t minus 1. Now this is 16 and this is also 16. So we can cancel it and we are left with this. Now 2 to the power of t minus 1, 2 to the power of t. Here instead of a we are having 2. 2 to the power of t minus 1 by t. We need 2 to the power of t minus 1 by t. So we must divide and multiply by t. So this will be 2 to the power of t minus 1 divided by t into t. And here also we have 4t minus 1. 4 to the power of t minus 1. So we need t here also. 4t minus 1 by t into t. Now these two cancel and we get the answer as how much will this be? This is a log of 2. So this is log 2 over log 4. This is log 2 by log 4. So this will be log 2 into log 4 is log 2 square. This is 2 log 2. So this is 2 log 2. These two cancel and we get the answer as 1 by 2. Now for continuity, what we have is limit x approaches to fx must be equal to f of 2. And this implies this limit is half. This limit is half and value of the function at 2. Value of the function at 2 is k. Value of the function at 2 is k. So this implies k is equal to half. Answer. So before starting this question, we were able to see that this question depends upon this formula. And we reduced it into this one. First change it into zero limit and then simplify and make use of this formula. If the function fx defined by fx is equal to this much is continuous at x equal to 0, we have to find k. We have to find k. Now the formula that will be used in this question is limit x approaches 0, 1 plus x to the power of 1 by x is e. Or we can also convert this formula into this form. Limit x approaches 0, take log both sides. So log of 1 plus x to the power of 1 by x will be 1 by x will come out. So we will get log of 1 plus x and this 1 by x will come out. So this will be x. And log of e is 1. So you can use the formula either in this form or log of 1 plus x by x is 1. So in this question we will use the formula in this form. Now for continuity we have limit x approaches 0, fx must be equal to f of 0. So first we find limit x approaches 0 of fx. This is equal to limit x approaches 0. Now x approaches 0 means x is not equal to 0 and therefore this definition will be used. So log of 1 plus ax minus log of 1 minus bx whole divided by x. This is equal to limit x approaches 0 log of 1 plus ax over x minus limit x approaches 0. We are separating this into 2. This is log of 1 minus bx over x. Then only we can use this formula. So to change this into this form, we separated these two. this is equal to limit x approaches 0 log of 1 plus ax. Now it is ax here, so we must make ax in the denominator. That is, we multiply and divide by a. Multiply and divide by a. And similarly in this, we multiply and divide by 1 minus bx. So we must multiply and divide by minus b. So this will be minus bx into minus b. Now this is in this form. So this will be equal to 1 into a minus this will be 1 into minus b. So minus minus is plus. 1 into minus b. If it is x, we must make x here. If it is say 1 plus ax, so we must have ax here. If it is 1 minus bx, we must have minus bx here. Then only this formula will be used. So this is a plus b. Now for continuity, limit x approaches 0 of fx is equal to f of 0. That is, this limit is a plus b. So a plus b must be equal to f of 0. F of 0 is k. K. Therefore, k must be equal to a plus b. Therefore, k must be equal to a plus b for the function to be continuous. Next question is, determined f of 0 so that the function fx defined by this becomes continuous at x equal to 0. Now, for the function to be continuous at x equal to 0, what should be the value of f of 0? Limit x approaches 0 of fx must be equal to the value of the function at that point. So, f of 0 must be equal to limit x approaches 0 of fx. So, first we find limit x approaches 0 of fx. This is equal to limit x approaches 0, 4 to the power of x minus 1 whole cube divided by sine x by 4 into log of 1 plus x square by 3. 1 plus x square by 3. Now in this question, what we see is we will be using these three formulae. Limit x approaches 0, for this we will have to change this into ax minus 1 by x is log a. This is known beforehand. For this we will use the formula limit x approaches 0 sine x by x. This is 1. And for this we will be using the formula limit x approaches 0 log of 1 plus x whole divided by x must be equal to 1. To make the idea clear, I am writing this in 3 different colors. Limit x approaches 0, 4x minus 1 whole cube whole divided by sine x by 4, and next term is log 1 plus x square by 3. Now we make the adjustments to convert it into these forms. So what we do is, here we will need x. So when I divide this by x, I have to adjust x cube. This is whole cube. So when I divide this by x, we have to adjust x cube. And here this must be sine x by 4. We must divide this by x by 4 and adjust x by 4 here. And in this we must have x square by 3 here and adjust it x square by 3. This has been changed into this formula. This has been changed into this. This has been changed into this. Now the question will be solved. This is equal to limit x approaches 0 for x minus 1 over x whole cube into x cube divided by sine x by 4 divided by x by 4, and x by 4 has been adjusted here. This x by 4 I am writing here. This is log of 1 plus x square by 3 whole divided by x square by 3, and this x square by 3 I am writing here. Now this limit will be log 4 to the power of 3. This x cube, this x cube cancels with x cube, and we are left with log 4 to the power of 3 into this will be 1 into this will again be 1 into this will be 1 by 3 into 1 by 4. This has been cancelled. So what we get is 12 log 4 whole cube. 12 log 4 whole cube. Now log 4 can be written as log 2 square. This is 2 log 2. So this will be 2 log 2 whole cube. So 2 cube will come out. That is 8 will come out. 12 8s are 96. 96 log 2 whole cube. Therefore, for continuity, limit x approaches 0 of fx must be equal to f of 0. That is, f of 0 must be equal to limit this. That is 96 log 2 whole cube. Therefore, f of 0 must be 96 log 2 whole cube. This is the answer. In this question, we are given a function fx equal to this much if x is not equal to 0, and 0 if x is 0. Now for x less than 0, the definition is this. For x greater than 0, the definition is again this. But this question involves 1 by x, and we have to discuss the continuity at x equal to 0. And we know that limit x approaches 0 from positive side 1 by x is equal to infinity, and limit x approaches 0 from negative side 1 by x is minus infinity. So we must consider the left and right limits separately. You can see the side sheet. So in order to discuss the continuity of this function at x equal to 0, we must find limit x approaches 0 from positive side fx. And this is equal to limit x approaches 0 from positive side. Now x approaches 0 from positive side, therefore x is not equal to 0. X is not equal to 0. So this definition will be used. We will have e1 by x minus 1 over e to the power of 1 by x plus 1. Now as x approaches 0 from positive side, 1 by x approaches infinity. So this is e to the power of infinity, and e to the power of infinity is infinity. So this is in the form infinity by infinity. 1 by x tends to infinity, 1 by x tends to infinity. Therefore, e to the power of 1 by x will tend to infinity. So this will be infinity, this will be infinity. So this is in infinity by infinity form. And in such questions, what we do is we change these questions into the form 1 by infinity. That is, we divide the numerator and denominator by e to the power of 1 by x. So this will be 1 minus 1 over e to the power of 1 by x. And this is 1 plus 1 over e to the power of 1 by x. Now as x tends to infinity, this will be e to the power of infinity. So 1 over e to the power of infinity will be 0. So 1 over infinity will be 0 and this will again be 0. So this infinity by infinity, which is an indeterminate form, has been removed and we will get the answer. So what we do is we divide the numerator and denominator by e to the power of 1 by x and change this question into 1 by infinity. This we have done in your previous class. As an example, you can see the side sheet. What we are doing here is, in this example, we are dividing the numerator and denominator by x cube, changing whole of the question into 1 by infinity form. You can see the side sheet. And the question is solved. So on similar lines, we do it here. So this will be equal to, now this is 1 by infinity, so this will be 0, this will be 0, and answer will be 1. Infinity by infinity form has been removed. The indeterminate form has been removed and we will get the answer. And for limit x approaches 0 from negative side, fx is equal to limit x approaches 0 from negative side, e to the power of 1 by x minus 1 over e to the power of 1 by x plus 1, because as x approaches 0 from negative side, x is not equal to 0. So this definition will be used. So now this is as x approaches 0 from negative side, 1 by x approaches minus infinity. This approaches minus infinity, so this will be e to the power of minus infinity. So this will approach to e to the power of 1 by x will approach to 0. This will be e to the power of minus infinity. E to the power of minus infinity, this is 1 over e to the power of infinity, and which is 0. So this will tend to 0 and this will also tend to 0. And so the answer will be 0 minus 1 over 0 plus 1. So answer is minus 1. So what we note is limit x approaches 0 from positive side fx is equal to 1 is not equal to limit x approaches 0 from negative side. Therefore limit does not exist and therefore the function is not continuous. Therefore the function is not continuous at x equal to 0. Therefore the function is discontinuous at x equal to 0.